Gator Recycling lowers the price it charges for its trash compactors from $6,400 to $6,000, and as a result, weekly sales increase from 70 units to 90 units. Using a linear approximation for demand, what price would maximize profits from these trash compactors if the constant variable cost is $4,000 per unit? So we're going to use a line to approximate demand, and we know that lines are in the form of P equals A plus XQ, where A is the intercept on the y-axis or the price axis, and X is the slope of that demand curve. To find the slope, we're going to use the change in price over the change in quantity, which is rise over run. Plugging in our points, we know we have 2 points, a point at $6,000 and 90 units, and a point at $6,400 and 70 units. So, doing a little algebra, we see that we have negative 400 over 20, which is equal to a slope of negative 20. We can now plug this back into our inverse demand function to get P equals A minus 20Q. Well, now we need to solve for A. We can do this using either point. We have that point at $6,000 and 90 units, and we have that point at $6,400 and 70 units. So we can choose either one. It will give us the same answer. Let's choose $6,000 and 90 units. So for price, we plug in 6,000. For quantity, we plug in 90. And now we can solve for A. So adding 1,800 to both sides, we see that A is equal to 7,800. We can now rewrite our inverse demand function as P equals 7,800 minus 20Q. Now we know we can maximize profit to find the optimal quantity and the optimal price to maximize profits. And the profit function is price times quantity minus marginal cost times quantity, where price is equal to 7,800 minus 20Q times quantity minus $4,000 of marginal cost times quantity. Taking the derivative of this with respect to Q, we get 7,800 minus double the slope, going from 20Q to 40Q, minus 4,000 equals 0. Now we can combine like terms and get 3,800, add 40Q to both sides, is equal to positive 40Q. Divide through by 40, and we can solve for our quantity is 95 units. So the price at 95 units, we just go back into our inverse demand function and plug in 95 for Q, and we see that the price we want to charge to maximize profits is $5,900.